obviously it's going to be a two-tailed test, but are you going to do 0.01, 0.02, 0.05, 0.1?
She just told me in class 0.05, so I figured that was the only one you had to use. I didn't know the
No,
option.
because, I mean, if you're going to have an alpha, you can either use, because normally in scientific papers, you're always going to have an alpha of either 0.05. This is always safe, because if you change it to a percentage, it means that it's going to be 5%. I don't want to mix up my vocabulary. Just take it with a grain of salt. But if you change this to a percent, it's saying that you have a 5% chance that it's going to fall into a region you don't want, and then a 95% confidence level that it is.
Okay.
But the higher the confidence level...
That's kind of what she taught me too.
Yeah, but just keep in mind that confidence and...
Change like that.
Yeah, but it's kind of like the confidence and testing this it's a different test, if that makes sense. If you want to find confidence, you have to use a different test.
So I'm not looking for confidence,
No.
I'm looking just for the exact answer.
Yeah, you're trying to find the correlation between two populations. You're trying to see if there's any statistical significance. If there is, then you can keep doing more tests to see how confident you are, if there's an actual correlation between the two, and things like that.
Okay.
So for your T critical value, if you're going to choose 0.05, it means that each of these regions, right, you had to divide this by 2 because you have two-tailed tests.
Okay.
So that will be 0.025 for this region and that region. So based off of your 0.025 and your degrees of freedom, which is n-1, n is your population, or like the number of participants. I guess
15.
So 15. So then that'd be 15 minus 1 equals 14. So your degrees of freedom will equal 14.
How come online it said it was 28?
I don't
It
know.
was doubling it for some reason. It's weird.
It's probably because, were you taking the average values?
Probably.
Yeah, no, you can't take average values. So degrees of freedom, n is your population, minus 1, which is 14. So based off of this graph, you go down to 14. And then since you have a two-tailed test with 0.05,
Maybe 2.145?
oops, 14, 2.145, yes.
Okay.
So your critical value, what was it?
145.
145. Because this is on the left-hand side, it's going to be a negative. On this side, it's a positive.
So they're pretty much the same thing, just with different names then, kind of?
Kind of. It's because you have a two-tailed test, you're saying that no matter which direction you go, they're going to be the same.
Okay.
Because if you have a negative value, think of it as just taking the absolute value. Like, you can't have a negative number. But in either case, it's going to fall in this region. If it does, you need a set point that cuts it off from when it matters and when it doesn't matter.
Okay.
So if your T critical value is negative 2.145, now you need to find your test statistic to see if it falls into these regions. And because you find your critical value, you can tell if it does, because if it's greater than this or smaller than this, it's going to fall in the middle region.
Okay.
Meaning that you're going to reject your null hypothesis.
Which is good.
You disagree.
Oh, disagree, reject. So reject the null hypothesis is bad.
Yes. Because then that means you're supporting this, that there is a difference between the two populations, but that's not what you want.
Yeah.
You want to see if texting and eating are just as dangerous. That's what the null hypothesis is claiming.
Okay.
Texting and eating are the same. So if you fail to reject it, you're agreeing with this.
And then if we reject it,
Then you're agreeing that there is a difference between the two. And then that's when you do more tests to see, is one more dangerous than the other? And that's just a whole different test.
But we don't have to do that.
Yeah, no.
Oh,
You're just
thank
trying to, you're just trying to find out between the two populations and what your original claim was,
Okay.
to see if there is a statistical difference between the two. So you find your T critical value, And because it's a two-tailed test, it can fall in either of these regions.
Okay.
So when you find your t-test statistic, it's like this big jumbo formula.
I would have failed if I would have never seen you in here. My goodness.
I took stats twice.
Oh, wow.
Because, no, it's not that I did bad, it's just when I took stats in community college, it didn't count here. So I had to take it again. I was like, whatever.
Your dad's a stats teacher?
Yeah, he's a math professor here.
Nice.
He teaches all the math. I'm like, eh.
That must be not. You could be a math major.
No, he made me minor in math. I'm just like, I don't like math. Anyways, so in order to find your t-test statistic, this is the formula that you have to use. This isn't the right variable, but I was sleepy last night. So, you know that this will equal 0, because if you look back at your null hypothesis, your first mean and second mean equals 0.
Okay.
Right, so this equals 0. So now, if you plug in your values, what is the average of your first population? Which is texting, I guess.
1.45.
1.45. Okay. So 1.45 minus
1.34.
1.34. So keep in mind, this is your first set of sample
So
of
it's
your entire
texting.
population, which is
Yeah.
texting.
Okay.
This is eating.
Mhm.
And then because this equals 0, don't need to do anything.
And then
You find the
standard
square root.
deviation
Yeah,
squared.
standard deviation, which is what?
0.55.
Are you sure? Because when I did it on Excel, it was wrong.
That D did it for me. How would I?
What's the
like,
formula?
double check?
Standard deviation of B2 to 16. Yeah, that should be right. Okay, yeah, the number looks right.
So just do 55.55 times.
Yeah, so then, sorry, what was it? 0.55. And you're gonna square that number
0.3025
for
that squared.
for that squared. Okay. Oops. Sorry. Okay, we'll do that. So 0.3025, and then
I'll do the other one.
0.49 squared
And then the top is 0.11.
for this one?
Yeah, for this.
Oh, for this one. Okay, so 0.11.
And then 0.49. 0.2401.
2401. Okay, so this N1 and N2 is the population, or not population, the sample size. So since this is your texting, right?
Yeah.
Texting. How many people were in the texting group?
Though it was the same group of people. They did texting and then they did eating right after.
Oh, okay.
So 15 for each.
15 and 15? Okay. So 15 and 15. So then now you would have to find your test statistic.
What happened to the degrees of freedom? We don't use that yet?
No, degrees of freedom you only use to find your critical value. That's it.
okay.
Because remember, you need to find out where this number cuts off so that the number you find falls within this range.
Okay.
So if you get this, you have 0.11 divided by square root of 0.3025 divided by 15 plus 0.2401 divided by 15. 1, 2, 3. I'm pretty sure that's it. Ah, dang it. Okay, hold on. 0.3025 divided by 15. So that would equal. Oh wait, I'll do it later. 0.2401.
I can do these ones on here if you want.
So you add that to so you should have a t-statistic of 0.578.
Okay.
So if this is your t-statistic, where does it fall in? Into this area, right?
That's bad.
So t-statistic equals 0.578. So that means you reject the null hypothesis. So the null hypothesis, you reject this, saying that texting and eating are not the same. There's something going on in there.
It's not telling us though which one is.
Yeah, it's not telling you which one is worse or better. You have to do a different test for that.
I don't have to know that, right?
No, I don't think so.
You're
You're just saying, because your original claim was saying that texting and eating are no different. They're just as dangerous.
Yeah.
But since you rejected that claim, you're saying, oh wait, texting and eating, there's a difference. So in your discussion, you can say they're based on our statistical analysis. It seems to be that there is a difference between the two. And in further studies, you could do this, this, and that, and then find the correlation or whatever.
Whose socks are these?
So as for like my actual graphs, did I just get rid of the no stimulus and no stimulus and just simply compare?
You can, but it's just more information than you need to provide, because the no stimulus, if someone, like, since I don't know what your study's about and I'm looking at it, I'm like, oh, okay, I'm going to be comparing doing nothing while driving and then compare it to texting, and then doing nothing and then comparing it to eating.
Oh, that makes sense.
That was my first reaction when I saw your graphs.
Okay.
But that's not what you want, right?
No.
You want to compare whether texting or driving is different from each other or not.
That's what confuses me though, because she was saying on here, since they're so close, she was like, I think that your hypothesis is going to be true.
And your hypothesis
it's
was
not true. So it's like, it seems like the error range is wrong, because according to her, this looks like it would make it true.
Because again, everything is based off of your original claim. Because for me, when I did mine, it was different. I claimed that, what did I claim? Oh, blue. I claimed that there was a difference between my micro project. Like, there was a difference. And the competing claim was that there was no difference.
Okay.
And then my null hypothesis, it's always going to equal 0, meaning that it's always going to be the same. Alternative hypothesis, there's a difference.
Are you being sarcastic?
So when I tested that,
Do you not like
I found the critical values.
Yeah.
I did a
never had oatmeal.
0.05
Last time I had oatmeal,
alpha,
I
I
saw
guess,
Jesus before.
and
I saw last piece of
found out that my t-statistic fell within this range, which means you failed to reject the null hypothesis, meaning if I fail to reject this, that there's no difference, it's the same thing.
So you were right.
Discussion with sugar.
Hold on.
It beats the purpose of having oatmeal. Yeah,
Oh wait, yours fell within this range, right?
It didn't fall in here.
Oops,
Oh, good.
ignore me.
Then let me add
You failed to
something it.
reject.
I like caramel.
What? So I got
Sorry.
it. We got it right?
Yeah, so if you fail to reject this, sorry. Yeah, this is
Oh no, you're
good.
fine.
Okay, so that means,
Sweet.
yeah, you failed to reject this, meaning that your original claim was right. That texting and eating are just as dangerous.
Because it didn't fall in here.
Yeah, it didn't fall in here, meaning you didn't reject the null hypothesis. So anytime it falls within this region, the region in between the two critical values, you're going to fail to reject. And since yours was 0.5, it's less than 2.145.
Yeah.
So you're going to fail to reject, meaning your null hypothesis is true.
Okay. Thank you so much.
Does that make